Right. So hello, welcome to EEE145 lab section. I'm here to kind of give a supplemental video on how to do the lab 7 transformer protection, mainly because we are running with ETAP and there's a couple new modules we're going to look at. Okay, so the first things first is let me make sure I'm sharing our screen. So we're on the remote desktop. Let's load up ETAP 20 version 2021. Okay, so let's load up a little bit. On the side, we should open up our lab 7 document for transformer protection. So if you remember, we should open the document. We should use the lab 2 model, right? Because that was a previous lab we did the transformer. We built the transformer station, right? So I already have it here, my built version. So I'm just going to upload that one. Okay, so give it some time. So basically just what we're going to do is we're going to simplify the model by deleting one of the transformers and a couple of the loads. We're going to add some CTs, we're going to add some relays, and we're just going to program them, coordinate them, and check them, okay? So a lot of the stuff you've already done from the previous labs, so I'll go really quick. Notice I deleted one of the transformers, 2 of the loads. I added the CTs, so always just remember with CTs, you want to zoom in a little bit. Notice where the dots are, so when you're putting your CTs, the overcurrent relay doesn't really matter because it doesn't matter which direction the current's flowing, so it doesn't care about the negative or positive. But for differential, it definitely does. So you want to make sure that your differential, all the dots either point in or point outwards. I like to make them point in, so all the current coming in equals 0, right? That's how your differential works. Remember, you're gonna have to figure out your CT ratio based on 150% of your load current, right? And so that's the CT building part. You guys already done building CT, so there shouldn't be anything new about that, right? Oh, I'm sorry, that's 100%. I meant the load current should show, you should choose the load current and choose the CT ratio to closely match the load current, right? Without going over 5 amp secondary, okay? So let's assume you guys did all that. The first thing you should do after is let's check out this 87 relay. So we just place this 87 relay. Let's go into editing mode over here, just in case when you change anything. So remember, you always double click I renamed it 87T, but this is a different relay. Inputs, make sure you have the correct CTs you want for that. Output, make sure it goes to correct output breaker. Oh, by the way, you want to put a high side circuit breaker, this one right here. I believe the our older model did not have it, so there's a line. Just make sure you put this circuit breaker there, okay? So make sure this A7 relay will trip it. Notice that the breaker is inside the zone. This is that overlapping zone protection thing we were talking about before. It's always nice to put the breaker inside the zone in case something's wrong with the breaker itself. On the differential side, make sure that's percentage type, not high impedance, because I'll mess everything up. Make sure the differential is actually activated, and 20 milliseconds is typical time it takes for a overcurrent relay to operate. So you should be okay with that. So next thing you want to do is you want to check everything. So if you remember how you do this little lightning bolt. Let's check inside it. Let's check on the buses out there, right? And then, so for example, let's do it in here, right? So you see how we have a fault right here. So then we can check to see what happens. So you can see we have an 87 relay trip. I actually have a 51 as well, just because I installed a 51 device as well. You guys would not have this relay yet. You should only test it with 87 by itself. But if you remember, you have the little crosses with the circuit breaker just to make sure it works, okay? So that's pretty much all you need. You just want to check to make sure 87 relay is tripping when it's inside zone and should not trip when it's outside zone, okay? If it's tripping all over the place, that means you did something wrong. Most likely your CTs are not configured correctly. Okay, so now let's go ahead and go back to the relay. So the next step is we're going to do the high voltage overcurrent relay. So it's going to be on the high voltage side, right outside the transformer. So we'll double click it. So here I renamed it like usual. Input side, just make sure you have your phase CT here. We don't have to worry about differential ground and any of that stuff just yet. It's mainly just a phase one. Your output right here, make sure you're hitting the high voltage circuit breaker, right? Overcurrent relay, we're gonna do something a little different. Last time we used a Westinghouse manufacturer. This time, because we're by transformer, we're gonna use a 787. So STL 787 is your your transformer overcurrent protection. So, or sorry, your transformer protective relay, which has overcurrent. So go in the library, go to Schweitzer, go down to 7A7, right? You can even click function and say, I want overcurrent, just to like zero in on the model list, okay? So click OK. I'm gonna click cancel because I have everything ready set up. So then you have your overcurrent and your instantaneous. This is normally both are clicked on, so click off instantaneous. We just want to do simple things first, so let's only do the overcurrent one. You want to do U4 inverse, extremely inverse. Make sure you pick up ranges of 5 amp secondaries. Almost all the relays in the world are 5 amp secondaries. 1 amp secondaries are very, very rare. Figure out pickup for that that'll work for you. For now, the timed out, just put whatever. We're going to change this. I just put 7 for now. Okay. The main thing is make sure you have a 7A7. Okay. So once that's done, you go ahead and you initially set your relay. Right? Don't forget that your pickup should be 150% of your current, your load current. The next thing I want you to do is, it's like a little secret, in this transformer, double click it. Make sure you have ANSI ANSI standard activated. Okay. I think it defaults to IEC, which then we're not going to get a transformer damage curve. So you have to make sure you have ANSI damage curve. Okay. So go ahead and make sure that works. And then you're pretty much set. So what we'll do is we're going to go and then do a coordinate. We're going to check the time curves and coordination. So we're going to go back to our star protective coordination study, which we've done always, except we're not going to use this fault insert just yet. We're actually going to select everything and then go up here and use a create star view. So what this is it's going to create a time curve plot like this. Now, most likely when you first build it, it's not going to look this nice. We might have to, add some features in and whatnot. Okay, so first thing I like to do is zoom in because it's kind of a little small. So the idea is you have these time curves. Now, if you don't have these time curves, let's figure out why. First thing I'll tell you is this, you have this little name. It kind of shows you which time curves we're looking at. So this is T1. You can right click the T and actually click settings so you can see exactly what's going on. This secondary, the bottom curve here, this is my overcurrent relay from a high voltage side. Again, I named it that. 51 is your time overcurrent delay. Again, you can right click show settings to see the exact settings if you want. If you remember, my pickup was 7, my time dial was 7. Okay. Now, if for some reason this transformer curve does not show up and it's just a dot somewhere, again, most likely you didn't select an ANSI curve. Additionally, you could hit the T1, left click it, double click it, and it should bring up the transformer settings page on the protection side. Make sure your short circuit contribution is calculated, not user defined, right? We're not supervising. Supervised means there's an extra like layer on top, like a SCADA system overlooking it. We're not doing any of that, right? Fall frequency, make sure you have both. So you have two lines, right? Frequent means this is the one that you can hit, that you can hit a few times, you'll be okay. Infrequent one is the one that you hit it, you'll get damage. Okay. Apply curve shift, so we could shift the curve over to ANSI standard. The main thing is you want to make sure you have this plot line right here. You see, this is what it should look like. If you don't click display, it's going to be gone. So click display to make sure it's there. Okay. So again, I'm harping over it because it took me hours to figure this one out. Make sure you have the ANSI standard selected. Make sure you have this time curve is set up. If you just have two little dots here without this curve, that means you don't have the curve set up correctly. Okay. So come back out here, your two curves. So remember, for protection, we have order of operation, right? Because look on the left-hand side, it's seconds. On the bottom, we have 0.1, 0.3, 0.5, and 1 second, right? So you see, this is 1 second, this is 0.1, this is 10 and 100. So it's logarithmic. The more the time the fault is the more duration of fault, the higher and higher, the more time it takes to where, like, if a fault goes all the way up to here and hits this point, this overcurrent relay is going to trip. It's going to trip everything. Okay. If we don't have this, or it doesn't work and goes all the way up here and hits this is the transformer curve, right? And you'll probably damage it. So you don't want to let it get up there. We want to make sure that curve the curve is underneath it, which right now it is because I kind of just ballpark 7. Now here's a handy trick. You see, you can select it. You see this little dot right here. You can actually move it back and forth, and it'll automatically change your time dial based on what you want to do. You see? So we could get as close as we want. We could get as far as we want. I'm telling you, this is a godsend compared to the olden days where you had to sit there and just like redraw this over and over and over again. Okay. So one of the major design like parts of this is, number one, make sure the curves are kind of lined up together. The extremely inverse curve lines up with the transformer curve. So I think we're okay with that. You could choose other curves, but they'll be a little more wonkier, right? I mean, we could just check real quick. If you want to go over here and well, actually it might take too much time. If you want to use another curve, it might like end up looking like that, which doesn't really match the transformer curve. So always make sure it has roughly the same slope. Okay, so they're kind of form fitting together. The big trick is you want to make sure the curves have a little distance between each other, and the way you do that is through a time delay. So what you can do, ooh, did I mess everything up? Hold on. So I accidentally killed a window. So let's go ahead and go to your star view manager. I believe it was the third one right here. Oh, wait, I need to select them all first, then go to the star view manager, or we could create a new one. Let's create a new one, right? I'm lazy. Okay. If you keep doing this over and over again, I think you can only have 5 of them. And if you you run into an error that says you can't have more than 5. If that happens, you need to go to the second button, Star View Manager, and just select all of them and purge them and delete them. Okay. So you can only have ever 5. So I just deleted all of them. Let's just redo it. So select this group, make a new one. Okay. So this is what we had before. Let's kind of zoom in a little bit. Control mouse wheel. Okay. Maybe one out. All right, so there's a bunch of couple other things like T1 Union Rush and everything, but I won't worry about that too much. Okay, so let's go ahead, right click, let's get some settings, right click, let's get some settings. Okay, so the next thing I want to say is we need to figure out how much time delay do we want between the curves. Standard rule is half a second between the tip of the curves. Okay, and what I mean by tip of curves is between this point and this point. There should be 0.5 seconds. For the class, I'll say 1 second just to give us a little more leeway, but half a second is perfectly fine. A little more just for fun. Okay. So how can we tell the time exactly? Well, you have a fun button right here. This is your time kind of delay. So the way it works is you click it. Get out the drawing mode. So we'll click it, and notice you have this little arrow pointing up. You can select a specific curve. So let's select this transformer T1 curve right here. And then let's select the actual overcurrent curve. And you'll have this little like this little bar. You can actually slide around and see the time frames, and you can see delta T. So we want to go all the way to the very bottom, and then we have 0.86 seconds. So I actually want to sit here and move this around until we get about 1 second. So, right. So let's go ahead. We can actually move this a little bit closer so I could be kind of close to it. Okay. So I'm going to guess this. I might have to update a little bit. 0.5. So you kind of play around with it. 0.75. That's probably good enough. I want to eke it out. That might be 1.03. Worst case, I could double click it. So I could change this a little bit. So I want to be a little bit faster. So maybe 7.6. Okay. Right. Oh, no, I went the other way. Oops. Let's do 7.8. Right. I want this to be a little bit slower to get closer to the curve above me. Okay. So 1.01. That's good enough. Okay. So we have a 1 second delay between the two curves. Notice my tune time dial for me is 7.8. Okay. So that's kind of what you want to do to zero in. Again, yours might be a little bit different. Okay. So the main thing is you want to see this little time delay delta T. Okay. So that's pretty much, you're coordinated now. You're good to go. So that alone is, I think the quiz question is, what's the time dial you've chosen for this? Again, everybody's gonna be a little bit different because you might do 0.996 or something like that. Okay. So that's how you use your star coordination curve. Pretty much the third one is the next overcurrent relay is the exact same as what we did before, except you can use a 751 check your relays. settings. Coordination means you just get all three of them, put them together, make a new star view. Now notice I have the overcurrent relay down there. Notice I have three of them now, okay? So let's zoom in a little bit. So I have three of them here. And again, we could do the same thing. We could select this curve with the time plot and this one. And notice, let's go to the max here. We got 1.62. We could then move the secondary curve to, I think I said 2 seconds or maybe 1.5 seconds, I believe. Right, let me double check. Yeah, 1.5 seconds for the next one, just to give us a little more leeway again. So oops, we could change this, move it around a little bit till we get that 1.5 second delay just about right here. So 1.4 seconds, pretty good. I could probably play around with it a little more if I really wanted to. Okay, 1.4. Okay, I'm okay. 1.49 seconds. Double click this, see what your time dial is. That's what's going to happen, right? So last thing, little tidbit. You don't really need a lab, but just to show you, you have this arrow right here. This is your fault current. So we did fault analysis. I think like mine has like 27,000 or something is a fault current. So we're right about between 10 and 30. So this is what the fault current looks like. And as time increases, it goes up. So let's say we've been online for 1 second. So 1 second is all the way over here. Let me get some drawings. 1 second is about right here. So if I cross-reference that, 1 second will put my dot right here. So at 27,000 amps, 1 second, we're right here, okay? So as the time keeps on going, we're going to keep on going until we hit this point right here. Once we hit about this point here, which is, I'm sorry, that's 0.1 seconds, right? This as the fault current goes up, it hits that first line. That's going to be about 0.4 seconds. And then if for some reason that one failed, we're going to keep on going up. We have a backup protection, the second overcurrent relay. That's going to trip about 2 seconds. And if that fails, we're going to hit the transformer curve and it's going to damage about 5 seconds. So the transformer says I can only take 5 seconds of this max fault before I get hurt. So we have 2 lines of defenses to make sure that doesn't happen. So let's hope and pray it works, right? So that's pretty much the main part of doing the curve coordination. Very, very important, powerful tool because you don't have to do this by hand anymore. Okay. In the labs, I have kind of some images to show you what it should look like in case it doesn't look like this. By far, the hardest part is making sure everything like shows up in the correct order. Once you have all the curves on there, it's just a matter of just moving it. You're done. Okay. So I'm telling you, the hardest part is just getting the actual curves online, making sure your relays have the correct settings and whatnot. Okay. The very last part we're going to do is we're going to go ahead and check the actual fault coordination. So for example, we have a fault right here. We expect the overcurrent. There are 2 things that's going to happen. There's 1 and 2, right? The transformer relay should operate. Differential relay should operate. The backup should operate as well, right? You do another fault on the low voltage bus and you'll see which breakers operate in what order. And then you can always go into sequencer viewer, just like last lab, to see the order. Okay, and I think that's the last part. You're gonna check the transformer to make sure that the circuit breaker is operating and the relay is operating in the correct order. Same thing for the feeder protection. Okay, so I think that's all there is about learning the star view coordination for this lab. So hopefully you guys have enough information and you could get started. Okay, so thanks for watching and let me know if you need anything else. You can always email me. Okay, so you guys have a good day.